This is an electric scooter in sharing, are everywhere, but of course also very expensive. Consider that you pay every minute that you use them, so the solution is just to go faster so you spend less. Unfortunately, there's a speed limit and you cannot hack it, but you can modify all the parts of this electric scooter that is in sharing, also your own electric scooter. So stay tuned, but first, intro. Now, the most complicated part is having here an electric scooter in sharing for 3 or 4 days, because it will take quite some time for me to record video and to modify everything and see if all the parts I'm going to cut fits perfectly on top of the electric scooter. And this could be pretty expensive. You can imagine that the more time you use an electric scooter, the more you are going to pay, and have it here still for 3 days will be pretty expensive as well. So the solution is just to save it for me for the lifetime. And I'm not joking, I have here in this box everything I really need to save it, and I'm talking about the Inspire 2 from Revopoint, and this is a 3D scanner, so let's see what's inside the box. We have this small tripod that works as well like a handle, so we can keep the scanner in our hands. We have this motorized rotating base, we will see this later, and we have also this polarized lens that helps us to scan objects also in a very, very bright light, maybe in outdoor under the sunlight. So the scanner by itself is pretty compact. We have all this technology in this small component, and we have also inside the box all these reflective dots that helps to scan complicated objects. And don't forget, under all these components we have this glass component, very well made, and we have all these black dots. Basically this is a base that helps us to calibrate the 3D scanner, so we are sure always to have the perfect measurement of all the objects. The scanner by itself is so interesting. We have 2 cameras that catch colors, so we can also capture the texture of the object, and we have also a laser scanner that uses infrared laser to understand the dimension and the distance of each point of the object we are scanning. We also have a small LED that helps us to capture better the images, so we can capture the texture of the object. But even if the LED is turned on, doesn't matter that the scanner isn't working. We can use the infrared laser beam to scan the object. So right now is turned off the LED. We are just capturing the depth of field of the object and the dimension. So you can see we have this small rotating base. This is so handy because it helps us to keep the scanner still and rotate the object itself. This, we can also do it in the opposite way. We can move the scanner and keep the object still. But because I want to scan something that is so huge and so heavy, I need to build my rotating base. So the idea is to find something that have ball bearings, so it's so smooth and spin without problems. We have to find something with a groove all around, so I can place the belt and make it turn. So I just found in my shop this broken wheel from a bicycle, and I think it could work because it has ball bearings, and if I mount it sturdy here on the workbench, I can then fix the problem that was spinning all bad. I just mount some spacers and a wood base here on the top, and now to motorize everything I recycled this. That was a car toy motor, and you can understand that I can place a rubber band just inside the groove of the wheel and on top of the groove of the small motor, and it's spinning. So yeah, I'm pretty sure it can spin the electric scooter without problem, and also the ball bearings will keep everything very, very smooth. So what I have to do now is just make a test. So let's bring everything into a huge room so we have much more space also here on the roof, because I want to make sure it doesn't hit the rooftop. So I need my computer, but you can also scan it using your mobile phone. You can connect this scanner via USB-C on the back to a computer or to your Android phone or iOS phone. And this USB-C cable is so handy, has also a little screw. That screw here here on the back, so we are sure it doesn't go away even if you move the hand very rapidly. So we can screw it here and connect the USB cable to my computer. I just downloaded the software for this 3D scanner and it's so intuitive. So we can choose multiple parameters by scanning. You can choose if you want to scan color or without color, if you want to have maximum resolution or just a speed of scan. So now I just took my old broken electric scooter so I can make a test before taking one in sharing. And let's make a test. So I'm trying here for the first time scanning this huge object. We have multiple problems. The first one is that it's too big for this base. The second one is that the base is spinning too fast, and also the object is too dark. It is completely black, and this is a problem for any kind of 3D scanner. So we need to fix this problem, and I was lucky. So let's go to take one. And here it is, the first one. So I just took the first electric scooter next to my house, and unfortunately I have only 12 minutes left in the credit of the app of the electric scooter in sharing. So I really hope that these few minutes are more than enough to scan the parts I need. I'm going to focus basically on the back part and on the base of the electric scooter. So let's go to the shop and start to scan everything. So the time is running out. I can place the electric scooter on my workbench and it's so heavy. I can keep it there very, very sturdy, and I will move around the object. The object itself will stay still. So I have everything ready. The scanner is turned on, the computer is turned on. I only need to solve the black problem of the plastic. I'm talking about the cover of the wheel and the wheel itself. You can see that are completely black, and any kind of 3D scanner has lot of problems scanning black objects because the black surface can absorb the laser beam, and so the scanner isn't able to read it. So cover it with white dust works, and right now I'm going for a very, very fast scan. I'm not interested into having a very, very high detail texture of the object. I'm more interested into having all the dimension, the perfect dimension and the measurements of each component so that I can plan and project later on all the structure I need to build. I can keep an eye on the screen of the computer. Every time I see a green dot, means that it's scanning perfectly, and after 10 minutes I have scanned all the details of the scooter. So you can see in the software I decided to scan each detail of the scooter. So I start to scan the front part, then I scan as well a detail of the back, I scan also the detail of the battery on the front, and the software itself just with one click can merge and align perfectly all the parts we just scan and create a new file, a new model that is the representation of all the parts fit together. So I have everything. I can also cut and modify the mesh via the Revopoint software, and I can import the file into Fusion 360. So I have all the details of the back tire. I know the detail isn't perfect. I was such in a hurry because the budget for taking the electric scooter in sharing was almost finishing. I had only 15 minutes to solve two problems. The first problem was to cover with white powder all the black components of the scooter. The reason is very simple. In a 3D scanner, any model use laser beams to understand the dimension, the size and the shape of objects that you are scanning. If the object is dark or black, absorb all the laser light, and this doesn't reflect, and this scanner cannot read it properly, and so basically the black parts are almost invisible while you are scanning. Cover it with white powder or with white paint can help a lot, and in this case helps me a lot. As well, I went into the software and I decided to uncheck the color scan. I don't need to have color scan. I also unchecked the very high resolution scan. I just need right now to take the measurements. I don't need to have perfect details of the surface. I just need to have the width, the height, and all the measurements of the electric scooter. Because right now I bring it back in the street, I don't have it anymore here in my shop, so it is crucial for me now having all the proper dimensions, so I don't need to take a meter and run upstairs in the street and find an electric scooter and check it every time I need to manufacture something to modify it. So now I have everything here on my computer. I have Fusion 360, I can import the file, I use the file of RevoScan to merge and to connect all the section I just scanned. As you saw, I scanned before the back part, the top part, the under part, and the software is so easy to use and connect and understand by itself how to orientate and fit the parts together. So as you can see, this is the collage of all the parts. I would say it's not perfect because it took me very short time just to scan it very rapidly, but I have the right measurements. I checked them, I double checked them with a meter before bringing back things upstairs, so I'm sure that everything fits right now. Now, I need to find a solution. I cannot weld or cut the electric scooter that is in sharing, but I can take inspiration from this machine. This is a test bench where you can test the horsepower of a motor. So you can see that we have the back tire that spins, a stainless steel roller, and this could be a great idea. So the plan is just to connect here on the back tire some rollers and some gears. So let me show you what I found in the shop. Let's go. I want to use these gears that came from all the bikes. I have many of them. I have to now calculate the ratio between one another so we can bring the scooter from 25 to 40 kilometers per hour. Lucky for us, there's this website. I can draw everything and see and prototype the dimension of the gears. So I will say it's working. We have the rotation coming from the electric scooter tire, and we are bringing it to a new tire that touched the ground here on the right. We have two main problems. The first one is that the back tire is spinning counterclockwise. We are going at 40 but in reverse, and we also need to make a reduction so we have more torque. I think a ratio of 3:1 will work. So I have here in my hand the parts that solve all these problems. That recapping are: the first thing, we need to multiply the RPMs. In this case I was thinking about this pinion system. If this big gear makes one turn, this small one makes 3 turns. So we have a multiply factor, and we need also to solve the problem that the gear was spinning in the opposite direction of what we need. So I have here a solution for all the problems. And it's something that we already saw in a couple of videos ago. If we watch carefully the pinion here, you can clearly see that it's spinning with a ratio 3:1. So 1 revolution of the stainless steel pinion here in the middle, and 3 revolution of the tire. In this case, the middle part is spinning 3 times, but you can imagine that the tire as well could spin 3 times. So we have the perfect ratio, and also we have the opposite sense of rotation system that we was looking for. So you can imagine that the pinion is spinning clockwise, and the axle of the wheel is spinning counterclockwise. So basically is what we are looking for. This could work, so I only need the middle part, so I can cut away also these stainless steel rims all around it. So you know that I'm very lucky, and every time I find a perfect object that fits perfectly, but today I think it's incredible. This solved all the problems, so we have a reduction of speed from 3:1, and we also solved the problem of the reverse speed. So we have the opposite gears that solve the problems. So I import into Fusion 360 the electric scooter. Let's import as well this crucial component that solve all the problems and see if I can mount it under the tire, on the back. So let's scan it with the Revopoint scanner and see how it can fit inside the project. So this is the most crucial part of all the project. I need now absolutely to scan it so that I have the reference point of the pinion, where it's placed, how to mount center this underneath the electric scooter in sharing. So I need to scan it, and unfortunately you already know the problem. This object is too shiny, it will reflect a lot of light. I'm talking about the laser beams. These are infrared laser beams that are shooting out the scanner, bounce on top, and if it's too shiny and it's not opaque, it will read bad the object. So the solution could be like before, using some talc powder. I have it here, but you can imagine that I have to scan it in multiple positions So even if I place the powder here on top and then I move on the object, the powder will move, will fall, and I need always constantly to add more talc powder. A solution could be finding a way so that the powder stick easy to the object, but will be also easy for me to clean it up afterwards. So let me show you. My plan is to use some frying oil from the kitchen and some white cement. This is a much higher reflective point of talc powder, so I really suggest to use white cement. It's a cheap solution instead of buying titanium oxide. This will work okay. I prefer to use oil instead of water. Even water can help to stick the white powder on the surface, but water has two main problems for this application. The first one is that water has tension, which means that water prefer and tend to deposit with drop shape. So if we try to spread the powder on top, it will deposit not evenly. We will have like white dots all over the surface. And the other big problem is that water reacts with cement and gets hard and it sticks to the surface and it's possible to remove it. So using oil solves all these problems. Oil also helps the powder to stick to the surface, doesn't react with the cement, and the most important thing is that creates a very thin layer, thinner than water. If you think about it, like a drop of oil that falls into a pond, it starts to spread so large with a very thin layer of oil, and basically is what happened here on the mechanical components. You see that we have a very thin layer of oil that helps so much the powder to stick even vertically, and after a couple minutes this is the final result. So we have the object that is all covered with this white powder, and I can place it here on my work table, turn on the scanner and start to scan everything. I also position some reference point all around, but this isn't necessary because this mechanical component is so complicated that the software uses these complicated parts as a reference point. I decide to scan the object from multiple perspectives, so we have a side view, a top view, and all around. So I can then import all the files into the Revopoint software. And inside the software, as before, I can merge and align perfectly all the parts. Let me show you before how easy it is to remove the powder and the oil from the object. It's so easy. So I don't know why nobody else do this, but it's such a clever way. I can then import into the Revopoint software all the 9 files I scanned, the part. I can merge them and align them together. The software do this for me automatically, and you can see that all nine files are perfectly aligned, and we have all the details and the dimension of the mechanical part. So I'm so happy right now. I can then import the file. You can see the texture without the texture, but in this case I don't really need to have such a high detail of this object. I just have the measurements of the pinion and how high it is and all the dimensions. So I can then plan how to mount everything on the back of the electric scooter in sharing. First of all, let's put a pinion and then install our new blue mechanical component here on the back. Is aligned with the pinion, and then can mount all the other components. So we have other gears and also a big tire that comes from another electric scooter. This is black as well, so I suggested to cover it with white powder, and this is the result. Came out pretty nice, and I can then insert all the files I just took into the Fusion 360. I just draw a metal structure that will hold all the parts, and I also represented some chains, so I'm sure that also the gears are perfectly aligned. So everything will be bolted here on the foot part here of the electric scooter in sharing, and I will say this theoretically in the software will work. So this is a great idea. I just represented with the laser all the position and the size of each component. What I have to do now is just cut them with the right size and align them properly so I can weld all the structure without problems. Wow, I think it's so handy for me having here in my shop all the measurements that at the beginning was just on my computer and right now are on my workbench. This is so easy. I can then cut and represent all the other parts, and I can use this cutter to cut all the angles just as the project suggests me to do. So as you can see, that is a precise fit. Also here in the middle, I will weld all the components together and repeat this procedure 2 times, and after aligning properly everything on my fixture table, I can then weld the first metal structure that will hold the wheel and also the reducer and all the chain and everything. So it's coming great. It seems something you can buy in a shop, is perfectly aligned, and now it's time to mount the back wheel. So I decided to use this that was from an electric scooter, and it's a great thing to do because it has a disc brake here that is mounted with 5 bolts, and I can replace it using this gear from a bicycle. I just have to adapt this huge washer, 80mm washer with 5 holes, and align it precisely with the gear. So I can weld it and connect it with 5 bolts to the original wheel, and we have a very secure mounting point to the chain, so we can spin this tire without problems. Now I can weld the back tire on the structure, and in this case I have to be very careful to weld it properly. There will be no suspension, so this will catch any bump or holes on the street. And now let's modify the aluminum mechanical component. I have to enlarge this stainless steel gear with a bigger one. I can weld the 2 parts together. In this case, I have to be sure to have perfectly aligned, perfectly centered, and don't overheat at all the mechanical components. Otherwise, I can ruin maybe some gaskets or something inside. So just proceed a spot weld at a time. Let's do the same thing over here on the top with a smaller gear, just keeping in mind to keep the same dimension we studied earlier, so we can bring precisely the scooter from 25 to 40 kilometers per hour, and you can see that it's spinning perfectly. I don't overheat the part, so no bad noise and no obstruction are created inside. And I can use my plasma cutting machine to cut 2 circles ring that will be holders that will keep the aluminum mechanical component perfectly straight. You can see I can mount it precisely here. I also drill main holes just where the rings were, and then secure everything. So I just drilled so many precise holes. You see I place here inside all these nuts. Basically these aren't really holding the middle part of the wheel, basically are just keeping it from spinning. So what holds the weight and the torque of all this system is the precision of these cuts I just made. So we have these 2 big metal structure rings all around that keep it there, hold very sturdy on the structure, and basically this will stay sturdy and only the middle part will spin, and you can see that we have the opposite rotation of the gears with the ratio of 3:1. So you can see. And now finally I can weld the parts together. 2 spacers will hold the 2 metal rings exactly parallel, and this helps a lot also to weld this mechanical component to the structure itself. As the project was made, I am welding also a column that is slightly angled on the back and weld the reducer here on top. To make sure that it's perfectly aligned with the back wheel, the best solution is just to mount a bike chain and see if it works. It's spinning without problems. There's a little bit of slack on the chain, but I can tension it later. And now let's check what's missing on the project. For sure I'm missing these 2 small pinions on the left, so let's see how can I make them. So there is a roller that spins underneath the back tire of the electric scooter, and I think I have the right components in the shop. I'm talking about recycled parts as always, so I have 2 huge ball bearings and also a stainless steel tube that was a leg from a table, and you can see that the stainless steel roller fits perfectly inside. So we have ball bearings, and we need now to connect this small pinion with the same dimension as the project.
To make an axle, I recycled this that was a chisel, a very thick one, and as well repeat the same procedure, install a bike chain to make sure that everything is perfectly aligned. This will be welded here underneath, under the structure, and you can see that everything spins and brings torque to the back tire. So to solve the problem of the tension of the chain, I decided to weld this that it was a bike chain tensioner, and you can see that finally everything is spinning. We have a little bit of a problem, sometimes the chain falls out.
And so finally it's working. We have the chain that spins. If I move this roller, you can see I can bring traction to the back tire. Everything works theoretically, but sometimes the chain gets stuck or falls out. I don't know the reason, maybe the tension isn't correct. I placed the tensioner here on the top, a tensioner here on the bottom, probably is too tension, I don't know the reason, but I need to solve the problem. I don't have so much time, so the solution is very dramatic. I bought these stainless steel discs. The idea is to weld them directly on the left and on the right on each pinion, so the chain, even if it wants to fall out, it has to stay perfectly in the middle and can go anywhere. So let's modify all the pinions. I have more dimension of stainless steel disc, one also probably here on the back or here in the middle, and let's see how it comes out.
So the mod is very easy. I weld disc all around and install 2 new ball bearings to make a swivel point so that I can attach it on the back side under the electric scooter. So this will be the structure that will be mounted and bolted directly next to the base of the aluminum scooter. Okay, everything is ready. Let's cross the finger and now I can push the gas. Something is not working. The prototype I just built works perfectly, makes no bad noise, the chains work smoothly, but I think the problem is about this electric scooter in sharing, because that electric scooter that are in sharing has this safety precaution that private property scooter doesn't have. I mean, this electric scooter, for starting to give full power to the back motor, needs to read that you are pushing with your feet a couple times. So you need to reach about 3 kilometers per hour, and in this case for me it's impossible because the scooter thinks it's still, because the speed meter is embedded inside the back tire. So even if I'm pushing as hard as I can, there's this free wheel that doesn't bring power to the motor. Because if you think about, we made all this project to give power from the front to the back. And in this case, this electric scooter is asking the opposite, so power from the back to the front. And if you apply this mechanism to your own electric scooter that doesn't have this safety precaution, it will work. I'm sure it will work, but in this case, we need to fix this problem. The solution could be 2 or 3. I can buy my own electric scooter. I can find another company that shares scooters that doesn't have these safety precautions. So if you know the name of a company that you just push the gas and it will go, let me know here in the comments below. Or the other thing we can solve is just maybe to add like string, like you know how you start chainsaw, that you have this starting string, and maybe twist it here. And maybe twist it here a couple times, so you just move and you see that the everything it will work theoretically. You can see that this has good grip against the wheel and everything will work. We just need to fix this problem, but I think it's fixable. So at this point, I want to upload the video like this, so you know overall idea on how everything works, so you can suggest me better how to solve it. And I want to also thanks a lot the sponsor of today's video, which is Revopoint. I used their 3D scanner Inspire 2. This was so handy and so precise, you see, that I also made the structure that fits perfectly on the electric scooter. Even if I don't own the electric scooter in my shop, everything fits at the first try after 1 week of welding and making all the parts. So at this point, see you next week. I really wish to solve this problem or with another do-it-yourself tutorial as always. See you soon. Ciao.
Thank you.